So John D, are you ready?
Let me turn that back off. Yes, I am set whenever you're ready to have me start.
So I just want to remind everyone, please make sure you have your ID in the chat for the raffle at the end. I'll be taking attendance midway through and at the end, and you have to be present to get the prize at the end. We have two prizes. They're from Matos Design, really cool prizes of Megatree toppers, I believe. So don't want to miss out on that. So make sure you have your ID and make sure you're here at the beginning, and at the end you must be present to win them at the end. So presentation is Megatree Tips by Jonathan D. He's a mechanical engineer from upstate New York. He's got a lot of experience with this stuff. So John D, the floor is yours when you're ready.
All right, thanks, Scott. Welcome, everybody. Glad you're still sticking around for the presentations here. I know it's been a long day of them, but a lot of good information and a lot of bouncing around for people. So glad to have you here and sticking through this. So like Scott said, I'm going to be talking about 10 tips for building mega trees. Kind of going to be some general information. If to get into specifics would take a lot longer than we have here, and I tend to be long-winded, so keeping this down to the 50 minutes or so is a struggle for me as it is. So I did have the thing here again. Thank you to Matos Designs for the sponsor of this presentation. They were been very generous with the donations for this. A little bit about me. Scott was a little bit off there. I am a structural engineer. I'm licensed in 3 states. I've got 20 years of experience. Most of that is in bridges. And the reason I bring this up is that I do know what I'm talking about with these things. That's important when you get into a mega tree. There's a lot of people out there that have had experience, but they don't necessarily know what they're talking about. Or when you're first getting into it, you don't know what you're talking about and what is good and bad or who to listen to. So I put this slide in here not to necessarily brag, just to say I've dealt with this stuff on a much larger scale. And this is why I'm giving these tips to people, what to look for, what to avoid, what to pay attention to. So I'm going to talk a little bit in the introduction about what is a megatree. Here's a bunch of pictures of megatrees that people use with all sorts of singing faces on them. They don't have to have faces. You don't have to have pixels. You can have whatever you want, just single LED type lights. But it's really tough to define what a megatree is. So basically, I just said, well, it's any type of pole or pole-like structure, because a lot of people use trusses, that you use to hang your lights off of. And I'm going to say it's going to be tall enough that it could fall over. And kind of the important part is to do damage. If you do something that's 4, 5, 6 feet tall, if it falls over, no big deal. You can drive those in with those little green fence posts or something like that. Use a piece of PVC. You're not going to have too much damage. When you start getting into 8, 10, 12 feet, that's when you start really getting into that. That can do some damage. That's a little harder. You need a ladder to get to the top of it. You get anything into the 16, 20 foot range, then you're starting to get even more dangerous. Over that, even more so. So there is no limit of how tall a megatree is, but I try to make these tips good for anything. And the bigger, the more concerned you have to be with it. So these are the 10 tips. I'm going to give them to you now just so you can take a look at it and see my 10 tips for it. Use guy wires. You got to pay attention to your anchors. You got to have a good base. You got to have a good pole. You got to have a good topper. You want to make sure it's level and plumb. You need to know how you're going to assemble it. Good, fast, and cheap. Those are all important factors with it. And a lot of people are too overconfident in what they do. And there's a lot of misinformation out there. So there's my 10 tips for megatrees. If anybody has any questions, I'd be happy to take them. I told you I was going to try to keep this short, and I did that. And obviously, I am just joking with that. I'm going to go into much more detail, but I like to joke around as much as I can and keep it kind of interesting for people. So please don't run away quite yet. So guy wires. Guy wires are probably one of the most important things and most overlooked things that happen with megatree. My simple tip for this is use the guy wires. Unless you absolutely positively know for a fact you will not use them, use them. They're cheap insurance. They help with a lot of things. Most of us are not designing our megatrees in the sense that we're not having an engineer come out, look at it, do things. We're not necessarily getting anything pre-built or pre-done. we're just kind of going out there, finding materials we can, using information we found online, putting something together and hoping that it's going to stay up. Guy wires will help with some of the weaknesses in the construction and the design of that and make things a little bit safer. It helps prevent tipping of the megatree as a whole. It helps to prevent bending of the pole. Really, there is no good reason not to use guy wires. The only reason people don't use guy wires is they don't have the space or they don't want to spend a little bit of extra money. But the small amount that guy wires will cost you to put on there for the extra insurance of keeping it from falling over, in my opinion, is well worth it. So use guy wires if it is at all possible. I've taken a few photos from a presentation I gave last year during the X-Essentials of some of the things. And you can see here, this pole had a very weak base, very poorly attached to it. No guy wires, fell right over. I don't know if this was during construction or during a wind. Guy wires would help keep this from happening. Same thing with this. The pole stayed nice and straight. Obviously this pole is a little bit, or the picture's a little bit crooked. Pole stayed nice and straight, but the top bent right over. Again, guy wires up at the top would have helped this from happening. There's a lot of things that guy wires will help. Bad connections at the bottom of your pole where it screws in. A lot of these pictures don't go together, but when you have pipe with threads, the threads are a weak point. They'll tend to want to break. They'll tend to want to fail. A lot of people have problems here. That's okay if you have guy wires holding up the rest of it, but if you don't and you're just relying on the stiffness of the pole, this breaks, your whole tree comes down. Another thing to pay attention to is guy wires only protect what is below the guy wire. This is pretty well secured here. You'd probably want a third guy wire, not just two of them here, but it looked like there was only one up at the top holding things. The other two, I don't know if they weren't installed or failed. Nice, the bottom stayed nice and strong, top ends up tipping over. You want to make sure you have three of them at all levels and they're very well secured.
Ryan's in Vinny's room.
Okay. So guy wires will help with this. Use them if at all possible. They are well worth the investment. Generally speaking, with guy wires, you want to install it as close to the top of your pole as possible. I realize realistically, you cannot put them directly at the top. You probably have a topper up there. You don't want the guy wires coming out in front of your lights. You kind of want them hidden behind your lights and that. It doesn't have to be right at the top. Get them within the top 2-3 feet. It depends how tall your pole is. If it's 16 feet tall and you put them 4 feet down, not a big deal. If you've got a 20-foot pole and you put it 8 foot down and you got a lot more sticking up there, that's a bigger deal. So as close to the top as possible with your guy wires. The bigger your pole is and the more transitions you have, like here, if you have a thick bottom section and a thin top section, add 2 layers of guy wires, 3, 4. It doesn't matter how many layers you put on there, they're all adding stability. They can come down to a single point at the base, but the more you have, the better off you are. It helps keep things secure. And if you have a transition like this from one to the other, put your guy wires above the transition rather than below it. That'll help secure this and take some of the stress off that weak point there with the connection. Anything you can do to get stress off the connection will help you in the long run. So if you haven't gathered it, use guy wires. It's always good to do. And I mentioned this with the other slide. Guy wires only protect what's below the guy wire connection here, nothing above. So the higher you go with them, the better. The more levels, the better off you are. At each level of guy wire, you want to use a minimum of 3 guy wires coming off your tree, and ideally they'll be at exactly the same angle in between the guy wires, which would be 120 degrees apart. If you have something like your tree is a 180 degree on the right-hand side here, this one kind of gets in the way. I know it's a pain, but you still need that there in case the wind blows opposite way and tries to blow things over. There would be nothing preventing it. Don't rely on your strips to be guy wires. They really don't have enough strength and usually aren't well anchored for that. So you want to use all 3 as best you can. If you can't get a perfect 120 degree angle, well, that's not too bad, but you don't want to stray too far. If these 2 back ones here are up and down on the page here, and this is a top view for those that didn't figure that out, if these 2 are in line with each other, you've got no support from on the back side here. So you want to keep these angles as close together as possible. If you can, use 4 guy wires, 4 or 5, keeping all the angles about the same no matter how many you use. Really 3, 4, or 5 is the most common. If you're getting up to where you're putting in 6 or 7, you're probably just overkill at that point. So 3, 4, or 5 is what I would generally recommend. Most people will do 3. 4 is semi-popular too. So that's my tips for guy wires there. Next, I'm going to go into anchors. The anchors of the guy wires are what secure that down to the ground. If you put guy wires in and don't have a good anchor, it was kind of pointless to use the guy wire. So that's why anchor comes right after it. You really want to use this. These are a couple of pictures of failed anchors here that just pulled right out of the soil. Nice spiral anchors, really good for really low weights, but as you start getting into much higher weight, it just pulls right out of the soil when you twist them in. It is also very, very easy to over twist these type of anchors. You're putting them in by hand. You're probably putting a piece of rebar or a long wrench around it. You're twisting it down and in. You turn it a bit too much, and all of a sudden, rather than having this come in like a corkscrew into the ground, it basically just cuts off the soil on each side of it. You give it a little bit of a pull, it pops right out of the ground like this, getting rid of any of the cohesion that was on each side of the anchor. Do not over tighten these. Very, very important not to do that. They're also very dependent on soil type. If you have a very weak soil that can't take tension, they pop right out of this. Christmas in the States is during the winter months when it tends to be wet in a lot of locations, tend to be snowy in a lot of locations. As soon as your ground gets wet, it loses a lot of its strength and it pops right out. These ones over here are your typical little stakes that you get at like your camping stores or Walmart or something like these. Never, ever use these. These are not going to give you any support whatsoever for guy wires. They're fine for putting your strips down to keep them from blowing around in a breeze and that, but they are not intended to take any tension really on them. If you hook up a guy wire to this, it's going to pop out of the ground. Maybe not initially, but over time, it's just going to work its way out. Do not use anything cheap and simple like this. You want to spend some money on these. You want to make sure they're going to go in. Anchors depends, the strength of it depends on a lot of different things. The length of the anchor, how deep you're going with it, however you want to say that. The type of the anchor, the ones that I showed there from Walmart are just a straight type. There's screw type. There's little anchors that kind of go in deep and then pop out like a little leg or something like that. Highly dependent on your soil type and soil moisture. Those are the big things, and a lot of people have no idea what type of soil type or moisture they have and forget that soil moisture changes over time. Also, if it's previously disturbed soil, first time you put it in, yeah, your soil probably wasn't disturbed or probably didn't have too much, depending on the age of your home and what went on there. If you just had a home built and they messed up everything, well, it could be disturbed. Every time you disturb the soil, it loses some of its strength and can be a problem. And even if you think you know your soil type, you might go, well, I got really clayey soil because when I dig, it's really tough to do. Well, just because you think it's clay doesn't mean it actually is clay. It might be something else from an engineering perspective. Geotechnical engineering is a very inexact science. So there's a lot of assumptions that are made with that. So there's a lot of variation in here. This is a snippet from American Earth Anchors, who designed some that I'll show on the next slide. But they basically go over, this is their caveat to all of this, that it's an inexact science in an inexact environment, and you don't really know what's going on. They kind of make some guesses to give you some general ideas how much strength their anchors will hold, but it's not anything that is real numbers that you can guarantee will happen. It's an informed guideline, not a guarantee. And that's where people get into problems. They think, well, this anchor said it was good for 100 pounds, or I went to Home Depot and I saw these dog anchors that are good for a 100-pound dog. Well, that doesn't mean that it's going to hold 100 pounds under every circumstance. It doesn't work like that. Ideally, everyone would have their soil tested and see, okay, this anchor is what I need for there. This is what the best bet. Nobody's going to do that. I realize that. Nobody can afford that. Nobody wants to spend that much money. Unless you're doing a really, really large tree, it's just not practical. The good news is their guides here at least give you an idea of the difference in capacity here. This again, American Earth Anchors here, there's their website. A lot of people use this. If you talk to the Walter Monkhouse, who's big in the Christmas lighting community, he will talk about these. I took their penetrator anchor here. They have a variety of different types with similar type charts. The important thing here is when you go from a 9-inch up to a 46-inch, look how much the load increases as you go in there. This is how much load that can be put on these anchors before they're going to pull out of the ground. Again, not a guarantee, but a decent approximation. Also, it depends on what type of soil you're in. The harder type stuff that you have, the asphalt type, that if you're going through a driveway, then you're coming down into sands and even just uncompacted fill, that kind of like stone that you're just placing there. You have almost no strength when you have just sand or something like this down at the bottom. Even when you're going from 9-inch to 46-inch, 750 pounds really isn't that much when you get into a sizable mega tree. It increases when you're going from 9 to 46, but only so much. And it increases as you're going up here and you get into your more dense type things. This is basically just a guide to say, well, look at this. What do you think you may need for this? And what do you think you could be able to afford when you're looking at these? These 46-inch ones, and if you had something like that, sand or that, you're getting 2,000 pounds of pull, probably will be enough for a lot. But these are going to end up costing you like 75 bucks each. Do you need that much? I can't give you that answer here. Every situation is different, but it lets you know that when you look at this, 9 inches, less than 100 pounds of pull, yeah, that's probably not going to be enough. You probably want to be somewhere up on this upper range. So this is where you should be looking. This is something that is very difficult. There is no one size, one type, all fits all anchor for everything. When in doubt, go larger. And you got to remember that your guy wires are useless without these anchors. So many of the megatree failures that I have seen pictures of are not necessarily failure of the guy wires themselves. They're failures of the anchors pulling out of the ground. Somebody didn't quite have them attached right, they pull out. It's very rare that you see these straps or the wire used for the guy wires fail. Very often it is the anchors. So when in doubt, go larger, spend a little more money there. I know it's hard to do because that's not anything anybody sees or that. Do as best that you can there. Remember too that you don't just have to anchor into the soil. You can use something like dead weight, put sandbags on top of that, attach the wire through to your anchor, and then go into a specially built block of concrete that has an eye bolt or something like that in. That's what the big antenna towers and that use. They come down, they go into a block of concrete and anchors there. What you want is weight so that that's not going to move around at all. So I think I've talked enough about that. Going to move on to your megatree base at this point. There's 3 things that you could do for your base, in my opinion. You can make it very heavy so that it doesn't move. You can make it really wide so that it doesn't move. You can anchor it to the ground so that it can't pull up off of that. And you can do a combination of these. You could make it all 3. Very rare that people will do all 3, but it is possible. The more of them you use, the better off that you're going to be with your base for being able for it not to tip over as you go along. So I'm going to show, this is the same picture I showed earlier with a base piece of plywood that it was anchored down to. Not only did it fail because it pulled off the plywood, but this piece of plywood here, not very big, not very heavy, not attached to the ground. If this didn't pull off of here, the whole thing probably would have pulled over. Meets none of the criteria. This is not a base that I would ever recommend for a mega tree. You want something better. Again, Walter Monkhouse, here's a website to his portable hole. This is probably the most common for your probably 10 to 20 foot range mega trees. He's got instructions on how to build this on here. It's a very good, simple system for being able to construct a base. It's relatively heavy, I think roughly 150, 160 pounds of concrete in a 2x4 base. And it's got positions here where you can anchor it to the ground. He's got 4 shown, but you can get up to 9 on there. But as I'll say in a few slides, you really need to pay attention to the instructions on here. The base alone is not very wide and realistically not all that heavy. So once you get some lights on here, get some wind going, this thing can very easily tip over if you don't have these anchors to the ground. The whole reason you put in these eye bolts is so you can anchor it to the ground. If you're not going to do this, this base is not that good. It's good for erection, good for getting your pole up initially, but then you immediately want to get this anchored to the ground, make sure that it's doing that before you put your lights up. Again, the more you can do, the better. If you look at his website too, you'll see where he extends this out with some extender legs in all directions, just based on some wood, and that gives you even more tipping strength. The more of the 3 that you have, the better off you are. You don't want your pole to tip over. As I said, follow the directions. Here's somebody here that made it. You can see here there's no anchors to the ground, or the anchors of this, just like I talked about with the guy wire anchors, pulled out. They don't look like they were attached. Maybe they were removed. But this is only mildly heavy. It's not wide, not anchored to the ground. It tipped. I'm not surprised at all that happened. Here's another one, very well anchored to the ground. You can see all 9 of them were used. Didn't have the greatest pull, had a threaded connection here at the bottom, but the base didn't tip over, the pole broke. That's a different design flaw. Not necessarily something we want to go for, but at least his base didn't tip over. It's one step in the right direction. Now it's just, okay, we'll get to the pole in a few minutes and see what we can do there. Our sponsor for this one, Matos, also sells some pre-constructed type things here that basically it's got 4 legs, kind of like the base for your Christmas trees, that you have legs that can go into here. The important thing on this one, again, not that heavy, not that wide at the base, and not anchored to the ground currently. You have to add the legs on here. I just kind of drew them in with some lines, but basically if you buy this from him, you'd need to get some type of steel that sticks out of here. It uses this little bolt to recommend it in place to make this larger so that it's not going to tip over. Spreading that out gets you something that's relatively heavy because the steel is heavy, relatively large base so it can help you out there. And then you can do something like add weights like sandbags on the ends of it to help it from tipping over. If you wanted to, you could probably even drill a hole through that, anchor it down to the ground, a lot of things you could do with it. So on its own, again, this right here might be able to stand your pole up initially, help you get something on here, but the strength really comes from the connection of the legs to this. Don't just buy this and put your pole into it. It's not going to work. At that point, you just may as well waste your time getting a artificial Christmas tree stand or real Christmas tree stand, put it out on your lawn, put your mega tree in it. Nobody would ever actually do that. You know it's going to tip. Don't do the same with this. Get the pole extensions that go in this. He does sell those, but you can also call a local steel shop and maybe be able to get it a little bit cheaper rather than shipping 20-foot lengths of steel or whatever you need. There's also a combination of the 2 of these. There's this little sleeve here that would drop into the pole here, into the portable hole. Again, if you're going to do that, you want to make sure that you anchor this down to the ground. Again, this basically just gives you another option for installing your pole. It doesn't increase any of the capacity of this. It doesn't have the legs at the bottom. The rebar in here is basically just to tie into the concrete for it so that it doesn't pull out. Good design being able to use the 2 of them together, but doesn't solve the problem of anchoring or extra weight with that. So, but the pole, this does provide a few eyes that you could anchor things down initially or connect his system for pulling it around. So that's all I have on the base. There's more I could talk about with that, but limited time, like I've said before. So now we're going to get into the pole. Don't necessarily go with just your cheap or easy to find pole. A lot of people will do this just for convenience. They go, well, I don't want to order something special. I just want to go to the big box store that's in my area, get something, make it work. That can work, but it doesn't necessarily mean it will work. So if you can find something a little bit more, especially now we're in July and talking about Christmas lights, you've got time to find something, to get it ordered, to get it shipped to you, find a way to get it there. Go something with a little more expensive, maybe a little more difficult to find. You're usually going to be better off. And again, just because it's round doesn't mean it's going to work. People will look at fence rail or top rail for a fence. That's usually not a good idea. That is very weak. It's not intended to hold much load at all. It's basically just intended to not sag that much and hold the weight of the fence. Fences weigh a little bit, but not nearly as much as a mega tree going up. It's fairly thin material. There are a lot of megatree designs out there, like Walters and that will use electrical conduit or some pipe. You'll hear people talk about all type of conduit pipe. The difference is which ones you're supposed to be using for which ones attach better together. The problem with pipes is pipes are all the same thing. And when you're talking about pipes, pipes are designed to be having pressure inside of them and not blow up. So you're really using that to transfer ideally fluids or gas, like the pipe in your house or connecting the gas, natural gas system or something like that. Some of the conduits are actually electrical conduits, and those are trying to keep water out of your electrical things and protect those. They're not designed to be structural. Things called tubes are what we use in structural applications. And tubes theoretically can be round or square. Most people think tube and they think square, but they can be round. They will sell them like that. If you call a steel manufacturer and ask for a round tube, they will know what you're talking about. Problem is, you can't just get those type of things at Home Depot or Lowe's or whatever you have nearby. So it takes a little more investigation to get something like that. Also, tubes will never be threaded because they're used for a structural application. Nobody is going to cut threads at the end of those. Things on pipes will very often be threaded because you're trying to screw them together because that makes a good connection for keeping the water or gas inside the pipe and not leaking out. That's what they're designed for. But when you cut those threads, you actually make a weak spot because from a structural perspective, when you're screwing it into another coupling, it's good for keeping the pressure inside it, but it's really bad from a structural perspective. And generally speaking, on your mega tree, your threads are going to be at a point of very high stress, usually at the bottom of the pole. That's why I showed in the previous slide, the threads that are being damaged happens very often because you over tighten it or under tighten it, it pulls out, it breaks, very easy, your mega tree can come down. Guy wires will help with that if you use them and you are using a pipe for this. I recommend not using a pipe, but if you're going to go with a pipe, make sure you use good anchors and guy wires with it. This is a little thing I want to point out here too when you're looking at things. There's several different bits of information with square versus round. Most people will use round pipe for making their mega tree. Round is a very good, efficient shape for using materials because at the same weight, well, let me just go back a second. I'll start over here. At the same size, if you have a square piece of steel, it's going to be stronger than a round piece that fits in the same thing. So if we have this square tube here and want to slide something inside it, there's only about 2 inches clear between here. You can fit a 2-inch diameter circle or a 2x2 square thing. If you have to pick what's going to go in there, the square is going to be stronger because it can fit more material out here at the corners than a round one can in the same area. However, if you compare the weight of this round one is going to be a little bit lighter than this square one, even though the square one has a little more strength in that thing. But if you had this square one here and made a round one in the same weight, the round one is going to be bigger and this round one is going to be stronger. The problem with that is it doesn't fit inside this hole here. So it depends how you're going to do your mega tree and what you're going to connect to at the bottom. If you have something like this that you're sliding something in, you're probably better off getting a square tube because that's going to be stronger and fit your hole the best. However, it's going to be heavier than if you had a round one in the same thing. You have to lift up that weight and get it into the air. That's sometimes difficult. If you look at just from a pure weight perspective, I can lift up this square one. Well, if you can lift up this square one, you can lift up this bigger, stronger round one. So there's a lot of things that go into here, and people will tell you, oh, always get a square is going to be stronger. Square is not stronger. Square is stronger when you're limited to a certain dimension. If you're looking at a weight, round is actually stronger when you're looking at that. So don't necessarily buy something just based on round versus square. Factor in what you're going to be connecting it to down at the bottom, how you're making that connection. And again, this is for tubing. You are not going to find square pipe anywhere, especially threaded at the end. That's just not a possibility. But the welds down here, they're only showing a tack weld here. This will be fully welded if you get something like this from pretty much anybody. There are different manufacturers that make them out there. This is all welded up. You can weld around square tube much easier than round. People will do it around round, but it's a little bit tricky to do, and you got to know what you're doing to do that. For the pole, look for a metal shop in the area. Like I said, get the tubes, either round or square, either would work. That's much better than just going to a big box store and getting anything that you can find. And try to get something steel, iron, something like that. Don't get aluminum unless it's a very large dimension and very thick. Aluminum is not made for this. It's lightweight, but it's not going to hold up. It's relatively flexible. It's not what we want to do. Don't go cheap on it. Definitely don't try to use something like PVC on this. It's not going to hold up. So now we're going to get into our toppers. The biggest thing I have on toppers is they are very easy to make. You look at it and it's like, oh, I can make something that's going to hold up there. But easy to make is usually easy to break. I have seen several pictures of people with wooden toppers. This is not the greatest photo because I tried to blow it up in on there. But when you have something like wood and you're drilling in all of these holes and connecting everything to it, all the holes make weak points in the wood. It allows water to get in there. It allows insects. It starts to rot over the years. You might get a year out of it, maybe 2 or something like that, but you're putting a lot of stress on that. It ends up snapping, it ends up breaking, and the whole thing falls apart. Very easy to make. Some of us might even be able to have stuff in our homes already that you can make it from without a problem. But I would not recommend using wood for that unless you have no other alternative, or a very, very small tree and you're not worried about too much on there. There are lots of loads that go on the topper that people don't really think about. They think, I'm just going to be hooking a few lights to it. But you've got the weight of your lights going on it, the weight of any strips that you have. There's a lot of those. People will think, oh, those strips are pretty light. But when you start adding 32, 64, or something like that, 16 feet long, really does add up in weight. You can get 40, 50 pounds on that pretty easy. And when you start adding everything together, it adds up. There's also the tension on those strips to get all the lights to hang nice and straight. Even just pulling a pound or two on there, again, you got 32 strings. That's 32 pounds of force that you're adding on there. Some people will connect their guide wires to the pole or topper, and then you're also adding the weight of that. You've got any wind that is hitting anything connected to it, and any weight of any snow or ice or anything else you may have on there. There's a lot of loads that go on to this. This one here, it's a plastic one, as far as I could tell from this. The problem is you got a lot of rings around here, a lot of lights, a lot of tension. It ends up breaking through that too. You got to realize there's a lot of load on these things. It's not just helping your lights stay apart. So you want to actually make sure you got a decent topper. I always recommend going with metal toppers. There's the Matos design here. Bascoyo sells some. Overkill Metal on Facebook sells some. Spend that little bit of extra money. Go with a metal topper. In the long run, you're going to be better off. If you're just doing a year to see if you like it, maybe you could get away with wood or plastic. But if you're doing this for the long term, you may as well spend the money, get something good, get something well designed that's going to hold up for a while. Don't try to skimp on that and have everything come crashing down, especially if you're going to try to attach any type of guy wires to it. Generally speaking, I would not recommend doing that. This is going to rotate. It's going to spin around and that, depending on how it's made. Attach your guy wires right to the pole, not to the topper. Most of these have holes here. The holes are for weight purposes or access purposes, not necessarily to attach your guy wires to. Moving on to level and plumb, and I probably should call this level, plumb, and square because the three kind of work together. But a lot of us will try to build something like this so that your base is nice and square, and you're going to put if you have a connection into it, you're going to make that nice and square with the connection coming out of the base to the bottom of the base. You put it on a level surface somewhere and you pour your concrete into it, or the prefabricated ones are just going to be nice and square because that's how you want to do it. But then you forget, if you're square between your base and the pole coming out of it, if you put it on something that isn't level, your pole isn't going to be level. And if you don't have a level pole, it's going to want to tip or it's going to want to buckle over. So this is the problem. If anybody here has done any home remodeling, you'll run into this all the time. You can either have things level or square with things like a doorway or drywall and that. You typically can't have both because people don't take the time to build things perfectly. That was the biggest thing I learned growing up as a kid, that my father would be trying to get everything in the house to be level and square, top and bottom. And when your bottom's not level, it's not going to be square and level at the top. It's just not going to happen. Same's true here. You want to make sure that you're accounting for the fact that your yard or driveway probably isn't level. This is one example where the base tipped over, and yeah, you could have this square on the foundation, but your foundation moved over on the one side, dropped on the right side, higher on the left side. It's no longer nice and plumb like it should be. You don't want your mega tree looking like this. This is still standing. Your mega tree probably isn't going to be if it's doing that. And we don't think about how unlevel something has to be to make a big difference, but an eighth of an inch per foot length, or what is a 1% grade slope in your lawn, is pretty typical. A lot of times it's even more than that. But if you have your driveway or your front lawn or that, you usually want to drain away from the house. So it's on some type of slope like that. Eighth inch per foot, you're not going to notice visually typically. But when you make a 20-foot tall mega pole, that's 2.5 inches of deflection from the bottom to the top. That's a big amount of deflection. If you're only using a 2-inch pole, you're already off from the center of the pole, or what we call eccentric loading, and your pole wants to bend, your tree wants to tip. You've already pre-put in a bunch of load onto the pole like that. So you don't want to necessarily have a nice square base that's going to be flat on the bottom with a pole coming straight up if it's not going on level ground. You may want to account for that with your design when you're doing it. If you've got a sloped yard, a bigger sloped yard, you want to account for that even more. When I talked about heavy, wide, and anchored to the ground, if you have a big slope on your lawn, you probably aren't going to necessarily be able to go wide unless you put some type of shims under it or do something like that. That's where you would want to go heavy as opposed to wide and anchored to the ground or in the ground or something like that. Guy wires seem like they can fully fix this, but they're really not going to. If you've got something at the bottom that's going straight up, the guy wires are great. If you got something at the bottom that's going off like an angle at this, and then you pull it back, that's going to put some bending into your pole. It's going to start to put all sorts of other stresses in there. Don't try to level with guy wires. Those can fine tune things. If you're just a little bit off and really anal about things, that's great. If you're trying to pull it back 2 inches, no, that's not the right way to do it. Level it up at your base, put something underneath it, get some sandbags, get some extra cement, do something there, even if you have to dig down into that to get a nice level base if you didn't fabricate it for it. You want to make sure that you get things level and plumb, or you will run into problems later. And as I said, a smaller base requires less level area because you're over less area or less length that you have to worry about, but it's more unstable than a larger base. So again, there is no one size fits all answer. You need to design for your situation. That's why a lot of these things that you see online, people talk about it and say, oh, well, I just use this one particular thing. It works great for me. Well, they might be in a nice plain area that doesn't have much of a slope at all. Then you get into another area and it's all hill, and you can't find anywhere bigger than a square foot that's going to hold anything level. Everything goes. So there is no one size thing. You got to design for your situation. You got to look at your particular details and make sure you're doing it for that. Don't just do what somebody else did because, hey, it worked for them. Look at your own situation and look at their details and if it will work for you. Going on to assembly. How are you going to get your pole up in the air is a big thing that people really don't think about. We've got things like the ASAP pole out there, and then people are saying, well, I'm going to get the Roan tower or something along those lines. Here's another one that's pretty much a lamp post or light post, depending on what you're calling it in your area. These things here, you're not going to pick up by hand. You need to get a crane out there to do it or multiple people to do it. That's an added expense that you're going to have. Will the crane lift it? Do you know how to assemble it if you have a crane out there? Is the crane going to tip over when you're trying to do it? We have had members in the community have things collapse when they've been lifting it up with a crane. That's really dangerous. You really got to know what you're doing. Will you have the room for a crane? You got to think about how you're going to get this up in the air, what's going to work, how you're going to get everything up there. These are extreme examples because they're pretty tall, they're pretty hefty to move in that. But even a typical length of pipe, you can get some pretty thick-walled pipe that's going to make a nice pole. You're not going to be able to stand it up on your own because you just don't have the capacity to do it. So think about how you're going to get this from a nice horizontal position like this, vertical and plumb when you're doing it, no matter what your base is. A lot of people don't think about this. They just start building. You get to the end, and it's like, I don't know how I'm going to get this up there. Now you're renting a crane or you're doing things very unsafely. And once you get this thing built up, if you have any problems, how are you going to get to the top to fix it? Let's say your topper breaks. Let's say one of your lights comes up unhooked. Can you get up there to fix anything? Do you have the means to be able to do that? Do you just leave it for the year? Do you call it good? I'm not sure what you want to do. That's really a personal decision. Some people will want to be able to fix it, some won't. But if you've got something 20 feet in the air and don't have a ladder to get up to that when everything's well spread out, you don't necessarily want to be running a bucket truck for every time you're doing that. So think about these things before you start to build. It really will pay off in the long run for you. Good, fast, and cheap. This is something that comes up in many businesses. You can have good, fast, and cheap, or good, fast, and cheap are alternatives that you can pick, but generally you can pick only two. Sometimes you can only pick one. And what it comes down to, if you want something that's really good, really nice, and you want it cheap, it's not going to be fast. It's going to take a while to get. You're going to have to put in some effort to get that. If you want it fast and good, then it's not going to be cheap. And obviously, if you want it cheap and fast, it's probably not going to be good. We, generally speaking, want to keep in one of the upper two here. We don't want not good. So that's why you're not finding something cheap and fast. But a lot of times, and especially as it's getting closer to Christmas and the deadline, and we've got all these other lights to put up, we go, yeah, I need to get this done right away. And I don't have a lot of money I want to spend on it. Let me see what I can get. It ends up not being good. It ends up falling over. We don't want to have that. So, but keep this in mind. It's not a rule I made up. You see it in businesses all the time that they talk about this. It's kind of a fact of the world. So, and when I talk about good, what I'm talking about good is safe and long lasting here. You want something that's not going to tip over. You want something that's going to last year in, year out. You're going to be able to reuse time and time again. Not going to tip over or anything like that. When I talk about fast, I'm talking about the time it takes to fabricate it or get it delivered, and even your setup time. If you're trying to get something that you're going to be able to install in a day, then it's probably going to be mainly prefabricated. It's going to take you a lot of time to be able to do that, so ahead of time. So fast kind of conflicts with setup versus fabrication. You can pick one of the two, usually being fast, not both. And cheap comes into both dollar amount and time. If you know how to do this stuff on your own and you can fabricate it yourself, you can spend a lot less dollars on it, but you're going to spend a lot more time. So some of these are not exactly an exact science type thing, but you have to make sure that, yeah, you're probably only still going to be picking two of the three, maybe only one of the three. It's very rare that you'd be able to get all three, if not impossible. Overconfidence. It happens to everybody. This is not an actual picture of somebody installing a mega tree, but you can see they've got the ladders sitting on a front loader here, a couple of them like that. The person that did this probably didn't think, oh, this is a really bad idea. They were confident that it would work, so they were going to give it a try. I usually don't see anybody in this community trying something as dumb as this, but it happens. We're overconfident. We say, well, I did this last year. It worked just fine. I can get away with it again this year. And also, I've seen this on the internet many times. Whenever you have a tie down strap, or I'm going to say when you have a mega tree guy wire and anchor, you're going to pull on that. You're going to say, that's not going anywhere while you tighten that up. But no matter what these are around and no matter who says that, occasionally you see something that was strapped down that fell off the back of the truck and is now laying on the highway, or you see a mega tree collapse because somebody said that wasn't going anywhere. It'll take any wind. It took 70-mile-per-hour winds this year. Well, they didn't quite follow everything. They forgot that they did something else the previous year, missed something. Something wasn't in as deep, or they put the stake in the same location as last year in disturbed soil, pulls out, the whole thing falls over. Don't be overconfident with everything. Make sure that you know it's not going to fail. Don't assume it isn't going to fail. The pole that I was showing earlier and here, this was a replacement for this pole here for one of the designs last year. Nobody thought this thing was going to fail when they designed it, but a 70-mile-per-hour wind came through, bent the thing right over, it tops over. This was a huge pole. You don't want to see anything like this go down because that's very dangerous. But even in your yard, if it's a smaller thing, you don't want it to come down. You put a lot of time and effort into it. No, it's not going to fail. Don't just think it's not going to fail. Don't say, I've done this year in, year out. I know exactly what's going on here. Make sure you're making sure all your connections are still secure, that you've got everything attached well, that you didn't just say, well, that looks good enough to me. It's a nice plumb pole. And then you didn't put a level on it. If you were to put a level on it, you find it's way off. So don't get overconfident with the things. I see that with a lot of people. Complacency, it happens to everybody. Not a bad thing, it just happens. Misinformation, this is a typical thing. You can find this with almost any profession. Don't just use a Google search and assume that you know more than somebody that has a degree in it, in my case, or experience building a lot of megapoles for a lot of other people. The granddaddy of megatrees is probably Walter Monkhouse. He's got a lot of experience. He's talked to a lot of people. He knows what he's doing with that type of stuff. He's done a lot of research on it. He just didn't do a Google search and come up with the first thing. There is a lot of good information on Google that you can find to be able to do things with, but there's a lot of wrong information out there too. People aren't intending it to be wrong. It just is. That's the nature of putting things on the internet. There's no control on it. So don't necessarily trust the first thing that you read or the most vocal person if you're on a forum or a Facebook group that says, well, I did it this way. This is the only way to do it. Look into it. See if it applies for you. See if it makes sense for your situation or not. It may not. There's no easy way to tell without knowing all of the details for yours. And so how do you tell the difference what's in misinformation, what's not in misinformation? Well, you got to do some research. Part of that is Googling, but don't just Google and pick the top thing. Start asking people, join a group, Facebook groups, the Zoom groups, coming to presentations like this, forums, the minis that are all over the place, the Expo, Transworld, anything like that. Start talking to people, see what they do, see if their situation is similar to yours. Ask questions of these people. Don't just say, oh yeah, well, what he said makes sense. Ask them some questions. Most of the people in this community are very giving and will talk about their stuff for hours, kind of like I'm doing here. You just have to ask them the right questions and they'll get going. Obviously, as we get closer to Christmas time, it gets more complicated and more pressure for them to do that. But if you ask somebody about their stuff now, you can probably spend a night with them and online or on the phone or something like that, get a lot of information from people. It's a very great community. And that's why I'm always giving back like this, is because people help me out like this. I try to help other people out. Also look for more than one source and don't just blindly trust the first source that you find is right. Try to get confirmation on those things. And keep in mind, there is very often more than one way to do it. There's more than one right way to do it. There's more than one wrong way to do it. There's a lot of different ways that you can put these things together. Don't just assume that one person has the right idea. That's the only way that you can do it. His poll seems to be the best. His base seems to be the best. There's a lot of different ways that you can do these things. So take a look at it. Make sure you're paying attention to everything when you're doing it. And make sure you spend the time and have that. So that's my 10 tips. Again, I'll just go over guy wires. Make sure you use them. Really, there's no good reason unless you have really researched it, actually designed your pole, or know that it's really, really rigid and there's no way to connect guy wires. I would say use guy wires in pretty much every situation. Don't skimp on your anchors. Anchors are usually your failure point of the guy wires. Make sure you use quality anchors. Spend a little bit more there if you can. Base, you want to go as heavy or as wide as possible, preferably both. Anchor your base to the ground if it needs it. Do all three is even better. On your pole, don't skimp on the materials. Don't just go to the big box store. Try to get something structural, not something that's designed for another thing that you're just making work. You'll be better off in the long run. Your topper, again, easy to make is easy to break. Get something metal. You're going to be happier in the long run with anything long term. Make sure that your pole is plumb. That's the big thing here. I'm not too worried about your base being level, but the fact is if your base isn't level and it is square with your pole attachment, it's not going to be plumb. You want your pole to be plumb as much as possible. Assembly, make sure you think about assembly before designing it and erecting it. It's tough to fix that afterwards if you don't know how you're going to do that right from the get-go. Good, fast, cheap, pick 2 of the 3. That's what you're going to get. You're not going to get all 3, so pick the 2 that you want to go with and learn from that. don't be overconfident in what you're doing. Take the time, make sure you get it right. It's the same with the electrical. Don't just plug things in because you've always plugged it that way. That's why we have all this safety information. Don't climb on your roof without a harness or a ladder. Nobody wants to see any accidents and megatree failures or personal injury or anything like that. And do keep in mind that there is misinformation out there. It's not intentional by anybody, but sometimes you have people that don't know what they're doing posting things, and you want to make sure you're not designing based on somebody else's bad idea necessarily. So with that, I think I kept it just about 50 minutes, which is actually very impressive for me. So thanks for everybody to paying attention. I see that we've got 200 participants. So thank you all for showing up for this. I hope you're here to learn something and not just here for the prizes, but if you're here for the prizes, that's okay. So now we'll open up to any questions that anybody may have. Got about 5 minutes for that.
So if you have any questions, feel free to unmute yourself and ask Jonathan about them.
Portable hole or sleeve in the ground?
I'm sorry, couldn't really understand that.
I say portable hole or sleeve in the ground.
It depends on how deep you can go with the sleeve and if you want something permanent. Really, there's no one that's better than the other for that. If you can get a nice piece of concrete in the ground and have a sleeve for that, that works great. The portable hole, however, you don't have to leave in your yard all of the time and move it around. If you're going to use the portable hole and you're going to anchor it down every year, that will work just fine. There's no problem with that. Same thing with the hole in your ground. If you want that out there and it's not unsightly to you and you have a way to cover it up so you're not going to hit it with your lawnmower or whatever, both will work. It really comes down to personal preference. Just don't make sure you've got like a nice 1 foot, 18-inch diameter piece of concrete holding up that sleeve. Go down below the frost line if that's a concern in your area. If not, at least 2 or 3 feet down. Make sure it's nice and heavy and in some suitable soil, not just in a sands area or something like that. Anything else?
So it's like I've got my flagpole, which is buried. It's got a sleeve it slides into that goes 2.5 feet into the ground, and that is concreted into place. Would that make a good base then, you think?
Yeah, that would make a good base. I'd be a little concerned about using just a flagpole, an aluminum flagpole, if that's what you're talking.
Not the flagpole. So if I can pull the flagpole out and put another pole in there, another tube in there.
Yes, that would probably work fine.
Okay.
If I was just going to put the topper at the top of a 16-foot pole, and it's a metal plate, what is the best way to, in other words, if I'm going to use a sleeve or bolt it onto that metal plate, what should I do where that's concerned? Should that be a certain length? Should that be bolted to the metal plate? Should it be welded?
There really is. If you can weld it's probably going to be your strongest, but welding isn't going to come apart. So if you bolt it to it, you have the ability to take it off and put it back on again. So I would think most people would probably end up going with something like bolted, but you could also have something fabricated that's like a sleeve that has a top on it so it can't drop down, kind of like a cap with the topper associated with it. So there's a few different options that you could have there.
Any suggested length that that sleeve should be that's going to go onto the top of the pole?
Yeah, I would make your sleeve, my gut feel is 6 inches long, but you could probably get away with a little bit more. You can always get away with more. It's not going to hurt you. A little less may be okay. You just don't want it popping off. It's got to be big enough and heavy enough that it's going to fit on there.
Okay, thanks.
Sure.
I have a question. Well, not a question, but a statement.
Okay.
There are some vendors that make a steel base for a megatree, and it uses square tubing that's welded four parts on the bottom and a center pole in the middle. And what it does, it allows you to put 2-inch steel pipe for the legs, and it sits on top of the ground. And
Correct.
it makes it really simple to assemble and put up. What you do is put two of the, I use 6-foot 2-inch steel pipe and put them horizontally, and then put the center pole in, lay it on a
This here.
stand or something. Yeah, there it is.
Yep.
And then once you get the horizontal pieces on and the pole mounted and all the stuff on it, then you stick one on the third part and use it for a lever.
Correct.
And 2 people can actually lift a 14-foot pole easily, even with all the lights on it. So
that's a good way of doing it, and that works out relatively simple for that. Something like the Portabase is not going to work as well for that because it's going to be harder to tip with the concrete like that. But something like this, where you can attach that lever to it, like if you had your 2 on this side, this one is a lever, and try to pry that up, it's going to work. You're putting kind of a lot of stress on this too, but probably not so much that it's going to bend if you're using a 2-inch.
Well, if you're using another person to help you lift it up, and then one person on the lever and one person on the pole, then it goes up fairly easy. So
So
anyway,
that's
I mean,
a nice method.
and that way you don't have to put anything in your yard. Now, granted, it's going to have you're going to have some poles on the top of your ground, but that's not going to show.
Correct. Yep. So that's a good way of doing it. Nothing wrong with that. That's it sounds like you've done it before. And again, that's good information for other people. That a nice way of doing it. It uses a base that's good, and we will be could work for you. So if anybody else has any other questions, I'm happy to answer them. My name was at the beginning of the presentation, Jonathan DePlanché. I'm John D in the X-Lite Zoom room, or in here most of well, not this particular room, but anytime I'm in Zoom, John D, if you have questions for me. Jonathan DePlanché on Facebook, feel free to reach out. If you have any questions that I can help you with outside of here. Want to get to the prizes, and then the Great Christmas Light Fight is going to be starting in room 1 in about 5 minutes. So